Hello everyone, good morning, good evening, good afternoon from everywhere you are. This is Mohsen from Microsoft Zero to Hero. I'm so happy to be here with another great session. Before to kick off the main session, let me share some information with you about the community. Yeah, today we have a Maik. He wants to talk about Azure Template Specs, and the topic is very interesting. As you know, we are part of Microsoft Learn community, and as you know, Microsoft Learn community is a hub central. There are a lot of content learning you can choose based off the certificate, career paths, or other things. And this is our specific November calendar women intake. Please register. Don't forget you missed your seat. There are a lot of topics you can enjoy. And the last slide is our code of conduct. Be aware of others, be friendly and passionate, be welcoming and respectful, be open to all questions and viewpoint, be understanding on different, and finally be kind and considerate to other in the chat, in the voice, in the question. And the time is to add Mike in the stage. Hello, Mike.
Hi all.
How are you?
Fine, and you?
Thank you very much. Are you ready for session?
Yeah, I'm ready.
Great. I add your screen the stage. Yeah, you
Okay.
can start.
Okay, that's great. So let's get started. So welcome everyone. And I have to tell you something today about the Azure Template Specs, one of the resources I sometimes use from time to time with my customers as well. So we will be diving in them in a couple of minutes as well. But I would first like to introduce myself a little bit further. I'm Maik van der Gaag. I'm a CTO with a company called 350 in the Netherlands, where we delivered skilled consultancy to our customers. Next to that, I'm a Microsoft MVP on the Azure platform, and I'm also a Microsoft certified trainer. So, like I've mentioned in the previous slide, we will be talking about Azure Template Specs. And I can hear some people think, okay, but what are Azure Template Specs? I never heard of them. And since it's already a very old resource as well, we still sometimes from day to day see customers, but also Azure technical people say, okay, but what are these things and how do they work? And what do they do? And basically, if you look at that, they enable a consistent deployment across environments with easy updates and parameterization. In a couple of slides and during the demonstrations, you will see how they practically work and what they are practically are. But it's a real cool enhancement if you are managing environments or if you're deploying to environments, but also want to help and assist your customers or maybe other technical people within your organization to do things themselves. Later on, you will totally see why and how basically it will work. So if you look at template spec, they are already GA since May 31 in 2021. It's already 2024. So they are basically already there for 3 years now within the platform and not that mainly known. It's just like any other resource in Azure. It's just another resource with also the main capabilities that you know of the resources that you have in the platform. And basically, as you can see here, it has its own specific resource type. Microsoft resources / template specs. And basically what it does for you in the technical form that you have, it enables you to share ARM templates or other kind of templates, and we will deep dive in there later on, within your organization, or basically within people that have access to your tenant. One of the important things that we have to inform you about as well is that they have a limitation. And that's approximately 2 MB in size, and that's basically regarding the template that will go into your template spec. And later on during this presentation and during the session, you'll totally know what I mean with that. So you have to be aware of the fact that you cannot make your template too large. So as I mentioned, basically template specs are a way for you to share your ARM templates within the organization, to make sure that people can reuse the templates that you created as well. So they are no longer only in a Git repository or within Azure DevOps. No, they are also within your Azure environment themselves. But basically, why would you like to do that? So if we look at a few things why you would like to do that, is basically you have standard templates. So it offers you another capability outside of your source control management system to share your standard templates. May it be a standard template for your VMs, may it be a standard template for your Azure App Services. It could basically be everything. So you can imagine that you maybe have some standard components for an Azure function. Basically, an Azure function, it contains the storage account, contains the function itself, your hosting plan, you name it, what you need for that function. You can create your standard templates for that and share them within your organization to be sure that everyone in the organization always does it in the same way. As you can see, the sharing capabilities of the template specs are just done through role-based access control. So it's not any sus tokens you need to send around and use to import your templates. No, basically you are sharing your template specs via the portal with role-based access control. So if you have read access, you have access to the template and you can use them as well. What you could also do with template specs, and what we have done in a practical form as well with a couple of clients that we were working with, we create so-called certified/approved products. Basically meaning that in many organizations you have security demands from the security department on how services need to look like, how servers need to be configured, do they need to contain HTTPS or not, access control via Entra. Those are all configurations that you would normally incorporate within your templates. And basically, in that way, you can make sure that when a new services get created within the platform, it complies to that security standards. Another cool thing about the template specs is that it has built-in versioning support. So if you imply the versioning within template specs, you make sure that people always use the latest one, but also can look back into previous versions that there are. Next to that, the template specs itself can just be integrated in your existing deployment process within Azure DevOps, within GitHub Actions, you name it. How you now work with templates can be totally compatible with template specs in the future. So I've been talking a lot about template specs, what they are, how they work, and why you should use them. So to give you some more insights on basically what it is, I would like to show you as well what template specs are. So let me move to the Azure platform. And basically, I'm now in a resource group within my Azure environment. So as you can see here is that we have a couple of template specs already available. And as you can see, they're just regular Azure resources. As they are just listed here in a specific resource group. And if I want, I could just click open up one of the template specs. So let me take the secured web app. And I can see here it mainly looks like a regular resource. It has some options. I can see, for example, the versions. This one is version 0.5. And I could also, on the left side of the screen, I can click on versions and I can see my previous versions as well and when they are created. Even clicking on a version brings me back to that specific version and brings me back also to the template itself. And like I've mentioned, it's called ARM Template Specs. So as you can see here as well, it's just an ARM template. And maybe you have noticed this already. It's generated from Bicep. And we will get into that later on during the session. As you can see that we can also use Bicep. So it's called ARM Template Specs. But yes, of course, Bicep for the win. If you look at infrastructure as code for the Azure platform, you could also use that. Going back to the template specs as well, you can still see here the complete version, the complete template, so you know what it does. And if we go back to the main resource, overview, you also have the access control. So you have access control capabilities for your templates, meaning that you have capabilities of making this readable for the people in your organization that needs to be able to create a secured web app. So depending on the template and on the structure you choose to be able to deploy your resources, you can make sure that they can use the specific template you want. And from this, for example, what I've done basically offers you just more than just saving the template. You will be able to, if you can read the template, to deploy it. And based on your access control within the platform, you would be able to deploy it to specific subscriptions or specific resource group, depending on your access right within the platform. So it completely complies with your access right within the platform, and it gives you directly a capability to start deploying that specific template. So as you can see here, it's referring to specific subscriptions. So this is basically just out of the box controls. And beneath there, you can see the specific parameters that I have within my template. As you can see here, we created stars in the parameters, in the default values. So we prefix them, for example, with specific naming conventions. These were a specific naming convention for basically one of our customers. And so basically they only need to change the stars, make sure that they have the right information, and basically click on Review Create. So it gives end users a very simple option to just start creating resources based on the information they have and the information they need regarding security. So they do not need to be completely aware of all security demands in the technical form, of course, because you make sure that everything from the technical perspective is completely saved within the Azure portal. So moving back to the slide. So cool, we have template specs, we have the resources, but how can we create them? Basically, what could work for us? We will see that later on during the presentation. But what I can already share with you guys is that there are, of course, specific comments. So basically looking at the main use points for Azure. So we have specific PowerShell comments where we can create a new template spec by using the new verb. We could get template specs within the platform. We could also set template specs. And basically what we can do with those template specs as well, we can also start off a new Azure Resource Group deployment by specifying the template spec ID and basically pointing it to a resource group. So basically this, the fourth PowerShell comment means that we are deploying the resources that are specified in the deployment stack. So basically what you saw me do within the portal, then basically done through PowerShell. For the C-line, it more or less is the same. So we have the AZTS create, AZTS show, AZTS list, AZTS update, especially to the set, and also, of course, the AZ deployment group create. As you can imagine here, for the new AZ resource group deployment and for the AZ deployment group create, there are, of course, also subscriptions variants, management group variants, and also the tenants variants as well. So moving on and more or less looking, okay, but how then does it work? So when you start working with your templates and looking at a way of how can I share these templates with my end users, you are, of course, are here where you have an ARM template or have a Bicep template. The only thing you basically will be doing is you will be publishing that specific template to the Azure platform by performing the command new AZ template spec. You will give it a name, a specific version. You would give it a resource group because the resource itself needs to be saved in a resource group. You give it a location, and then you specify which template you would like to have as a template spec. That will basically then reside to an Azure template in the Azure platform. And next to that, you will have the capabilities to start deploying resources specified on that template. So if I'm a user and I would have access right on that specific template, I would be able to get that specific template spec, like you can see here, from a resource group. And of course, I need to specify the specific version I want. This would give me basically the template specs with that specific name, with that specific version. And basically, I can then extract the resource ID from that version. And with that resource ID, I can then use the new AC resource group deployment command to start deploying the resources within the platform. Saying how this technically works makes me go to a demonstration on how to get started. So basically what we will be doing now, we will be moving to Visual Studio Code where I have my templates ready. I have some main templates ready. I have some scripts ready that we can go through and see how it works. So if we would go to our folder template specs, and basically we will now just start off with just using basic ARM templates. Very old fashioned, of course, I know. Later on, we will dive more into the innovative stuff as well. And as you can see here, it's just a regular template. It just contains specific resources. So as you can see here, I'm just using a web server farm that has a specific site. And you could call this maybe a certified product for a server farm. Not really a certified product because there are no fancy things in here, but it's just a regular template spec. So if I would open my script file, and let me just move over to demo 1, you can see here is that I have some specific comments in place. So basically I have a comment in place to build up my resource groups on top. And I then have on line 15 a new AC template spec. I give it a version number, resource group name, and location, and then point it to that specific template. And then I also have the options to start deploying it. So if I would take this script, and I still should be logged in. Let me just move up this version because I think I already have a version in my Azure environment. I would just, let me also, of course, execute this, because otherwise I would not have all the properties in place. I would spin up this, and normally this should be very quick in creating the template because there is nothing really specific behind there. And you already see that it already has been created and gives me some feedbacks. So basically it gives you the ID, the name, and the resource group where it saves the template as we specified. So basically moving to the Azure portal. And let me move to the correct group. Oh, that's the deploy location. Okay, it's not. It's from a quick start. So let me just do the sponsor RG template specs. And we deployed the web app. If I'm correct, we can see that I have a version 1.3. And if I look back, I also have that version 1.2. That's basically one of my tests I did this morning. And if I would open up the template, you would see that basically the template is exactly the same as I showed you within the Azure, within Visual Studio Code. Moving back to Visual Studio Code, for example, if I would be want to deploy this template, I could just execute this piece of code. Basically, this gives me the ID because it just directly connects to the platform, retrieves the specific version for a specific template that gives me back an ID, and then I would be able to start off this deployment, which basically makes sure that the resources specified in the template are deployed, and because of the default parameters I have within my template, it will not ask me for any parameters to fill in, or I'm not required to add those parameters to the PowerShell code as well. But you can imagine that when doing this and having required properties that are not do not have default values, you need to give those services as well, of course. So basically, this deploys the specific versions. And also moving back to the platform, if we could go to the template specs deploy group, we can see that we have done a deployment, and I can let you see that it's basically the time of now where we did the deployment. That's basically the deployment time. We can just see that it just deployed the two services that are in that specific template. What you could also do, of course, with template specs, and that's basically a capability that's in ARM as well. What you could do is, if you have specific templates that point to other template files as well, what you can see here, for example, I have a specified ARM template for storage, and I have a specified template for web apps, and I have another template that's basically linking to those files as well. This is basically one of the old concepts we had before Bicep, to be sure that we can split out our ARM templates, because ARM templates were getting a lot larger as well. But this also gives you the capability to just deploy basically linked template specs to the platform as well. And basically, it still works the same. So we still have the same comments in place, where we just have to publish the main template to the platform, and it makes sure that it also links in the linked templates. So as you can see here now, it's already deployed. So moving to the platform as well, and then we're to the specified resource group. Is this the correct one? It should have a new one. Yeah, there we have it. That's basically a completely new one with a linked template. You can see here that it automatically also adds the link templates. So we have that main template. That main template also points to the other templates as well. And it basically works the same as you saw within Visual Studio Code. And I'm also capable of pointing to those specified templates as well. Of course, this option also gives you the option to just start deploying it to the portal. And as you can see here as well, I also have to fill in an account name, because that does not have a required value. And it basically is the same for deploying it through PowerShell. But I think everyone gets the idea now. It's linked templates, all works. Great. So I think everyone already heard me mentioning Bicep. And I cannot even imagine if there are still people that do not completely know what Bicep is. But sometimes I see also in the customer space as well, in practical situations, where people are still starting up with Bicep and do not clearly know what Bicep is. So I have a short introduction here as well into Bicep. I will try not to make it that long, because I really want to stick to template specs as well. So for people that do not know yet what Bicep is a domain-specific language, especially built for Azure, especially built for setting up deployments through the Azure platform. That's it, basically a transparent abstraction on top of ARM, and it completely has the same capabilities of that you had in the days with ARM in Bicep. As you may have noticed already, all deployments done by Microsoft, by other partners, will mainly move all to Bicep. What you can see now as well, that was a thing, I think it was last month or even 2 weeks ago. If you sometime use the preview portal as well, you may know that you also are capable to export the templates, the ARM templates from your already created resources. In the preview portal, you now also have the capability to export in Bicep instead of ARM. So you see that the default deployment space is really moving to Bicep, but it's also good to know for yourself that it's still the ARM, the Azure Resource Manager beneath there that basically does the work. So basically what you see is that the Bicep files are basically getting compiled to ARM, and the ARM stuff is getting sent to the Azure Resource Manager, and the Azure Resource Manager then creates your resources based on what's specified in the ARM template. That is fully integrated with the Azure CLI and PowerShell, but maybe you're asking, okay, but why do we then have Bicep? That is because of the reason that it's far easier to write, especially with the extensions that you have within your specific code editors. But it's also much simpler, much easier to read. And as you can see here, basically in this slide, there are two files. Let me check if I can zoom in a little bit for the people. Not sure. No, it's not picking up my zoom. Let's just get back. So if you're looking at these files, you can see that basically they do exactly the same thing. It has exactly the same services, exactly the same parameters. But as you can see here, the one fits on one page. The other one isn't even finished on line 47. So it's far more better to read for your people and far better to work with as well. And you will see a little bit in the demonstration as well how easier it is. One other good thing to know about Bicep is that it supports modularization. So you already saw me using link templates, but in Bicep that works a little bit different. So you work with Bicep modules, and it really makes sure that you are capable of reusing already created Bicep files, because Bicep modules are just regular Bicep files that you can reuse in any other components. And basically those modules are able to be shared with the use of role-based access control, so that it works more or less the same as with template specs. But the cool thing is, in Bicep, if you write Bicep, you can use modules that are saved in a registry. So you could make the choice to have an Azure Container Registry where you publish your modules, but you also have the option to use Azure Template Specs as modules in your Bicep file. So you can really extract the components there. One good thing to know there is that when using Azure Container Registries, at the moment that you are building your templates, or basically when you send the deploy commands to the Azure platform, when using Azure Container Registry, the module itself that's saved in the container registry is completely in text imported into your ARM template. So it really gets to be one large template. When using Azure Template Specs, it will not import the complete template. What it does, it really makes it a linked template. So it makes a linked deployment. So you should also be aware of the fact. So for example, when sharing that constructed ARM template that you have created of a template spec, it could be the case that the people you are sharing it with do not have access on the template spec, so they will not be able to deploy it. And that's basically another point that you will get into with Azure Container Registry, because the container registry will completely import the complete ARM. Enough talking again. Let's go back to, and now basically the larger demonstration, where we'll also see some Bicep in action, some template specs in action, but also a form of automation where you can make sure that you deploy your template specs in an automated way, and also a way how you can construct them, and also make sure that it's completely automated with GitHub Actions. So let's get started with, first of all, a simple Bicep template. No, not that simple. If I would imagine simple, I would just pick the storage account. This one is a little bit bigger. It contains a server farm with some websites and does some additional configuration. But what you can see here, this template is just a regular bicep file that we can also use to create a template spec. So if we would look at the script for demo 03, we see here that we exactly use the same comments and directly point to the bicep file itself. So we are now not just pointing to an ARM template, but we are pointing it to the bicep template itself, meaning that the PowerShell action I perform knows that it will need to construct the bicep and then send the ARM template to the platform. So if we would execute this, yes, this one. Let's just wait a couple of seconds. You see the default warnings and sections coming from the bicep engine. So we know that it's in the background compiled to ARM, and then you will see that it's being created as well. So going back to the Azure portal, then going to this resource group, let's refresh the screen. You can see that we have an AC Temp Spec bicep web app, but also when clicking open now this main template, you will not see the bicep file, but what you will see is the compiled ARM file. So as you can see here as well in the metadata, it contains the bicep metadata and template hash that's being constructed at deploy time of the template spec itself. But this is basically exactly the same as we had within Visual Studio Code, but then in bicep, of course. So it gives you the capability to do your work in bicep, but also have capabilities to just add it to the platform as well. Like I've mentioned, here we used on the 02 demonstration, we used linked templates. So we had additional templates in a specified folder with JSON files. And in Bicep, the modularization works a little bit different. So if we would go to this Bicep file, you can see that we are now not using the resource keyword anymore, but are using the module keyword and pointing it to a specific Bicep file, as you can see here. And that Bicep file is placed in the folder .modules. So if we would look at the folder structure, you can see on the right side, left side, that we have a folder called .modules. And in that folder, we have a 001 storage account, Bicep. And basically, this is just a simple Bicep file with a storage account in there with one specific parameter we need to fill in. So it really is using the module structure of Bicep. And what we can do now, of course, is also deploy this as a template spec to the platform. But the biggest announcement in here as well as what you can imagine is that if you have large templates, you still make sure that you have your specific modules so that you have a good way of writing your ARM templates and writing your infrastructure as code to have a decent overview of what you're doing. So now deploying that piece of code to the Azure platform, what you saw with the linked templates on the ARM side, you will not be seeing with the Bicep modules. So you can see that it now is deployed to the environment. Let me refresh this. Bicep module storage. So here's the difference. As we are now using the module structure of Bicep itself, the ARM template itself gets constructed locally on your system and then basically sends to the Azure Resource Manager. So what happens underneath is that the stuff I specified in the module is now incorporated in my template. So it's it gets one large ARM template, and you do not have the linked template section anymore. So you need to be aware of that fact, that using Bicep, depending on the way you work, does not give you, by default, give you the linked template sections as well. Basically, one of the last demonstrations, and then we will move to the automation part, is basically certified storage. So you heard me mention it a couple of times. Certified storage really give you the option to specify how you would like a storage account to look like, which properties does it not need to contain, which configuration values need to be set. For example, by default, use role-based access control from Microsoft Entra. You can really make sure that in those templates, these configurations are in place. So this is just basically just a very quick example, setting those properties, deploying this template, and then in the portal, do not use, for example, if I go to the resource group, we use the create option to create new stuff, but just use the deploy options of your templates so that you are aware and are certain that all configurations that you specify in the templates are used, and everything is in fact handled directly on the services, so that, for example, you do not have to check if your Azure policies keep working correctly, to file all these things, or then that you do not have to write all these Azure policies to make sure that all your configurations are in place as well. So another thing that you can imagine, and that I also shared, so Bicep has a modularization standard built in, and you can use an Azure Container Registry or template specs as a module within Bicep. So what you have seen me do with the demonstration of 04 is where I use a local module. So basically this still means that the storage account that I've created is still a local template. So that's basically not very good for sharing, because everyone needs to have the template locally on his device, or within a Git repository, he needs to clone it. So you would like to have some online location where you can share that module or that specific template that you would like to use. And basically what you can do for this is setting it up in Bicep. So some part what you need to do there is add some settings in your bicep.config. So what you can see here is that I added a section called module aliases, where I've specified the module alias for TS, and then the alias template specs that I point to a specific subscription. So this is basically a specific subscription in my Azure platform, and I specify it to a specific resource group. And basically that resource group contains all my template specs that I have in this example. And what I then do within my specific Bicep file, I again use the module keyword. I use a specified name for my resource. In this example, I've called it automation, and then I pointed to the specific alias. So I've used the TS for template spec, a slash template specs, and then the double point, and then have the name of the template spec. So it's AZ temp spec certified storage, double point, basically the version number. So I'm pointing it directly to a specific version of my template spec. And the beauty of this is that I also have live intelligence to the parameters of my template spec. For example, if I would type in enter parameters, it retrieves basically the parameters that are specified in my template. In this example, the storage account storage SKU isn't a required property, so it's not flagging any faults, but it really finds my parameters as well. And for example, if I would remove one of the required ones, it should also underline it with a fault, meaning that we are missing one of the required properties, in this example, the storage account name. So I still need to supply it. And then storage name. So I've mentioned to you guys that the modules that I have here are added in my ARM template, basically the outcome of my template, as a linked template, and not the bicep itself is not incorporated in the template itself. I haven't got the file ready, but let me just show you guys how that looks like. It's in the bicep folder. Yep. And then we just do a bicep build. What's the... Yes, let me just see if it still works. It should, yeah. On the left side, you see a JSON file appearing. So that's basically the ARM file, and that's basically the file that normally gets constructed at the point you do the new Azure Temp spec with a bicep file. And normally you would not see it. It's all done in the back. But if we now would open this file, you can see that we have an inner deployment in here, with resource deployment, also with the name certified storage. You can see that it's mentioning my parameters. Then we also have, oh, let me get the IntelliSense out of there. Yep. A template link. So it's really linking to my online template, meaning that everyone that would use, for example, this ARM template, or even this bicep template as well, during deployment, they need access on that template spec. So you can imagine if you have an automation process that deploys, for example, this template, the user assigned identity or the system assigned identity or what kind of identity you are using needs access right on the template spec as well to be able to deploy this resource, to be aware of that fact. Then basically moving on to the automation part. So let me just open GitHub as well. I don't think I have it open already. So let me just open up a new window, drag it in here, and then just go to github.com. And device environments, organization. Yeah, I'm still logged in here. And in here, I should have a repository called template spec. So this is a public repository as well. So after this presentation, you want to look at template specs, how it works, and what I've shown you already, just go to this repository and you can just copy over and learn yourself from things that are already in here. If you have any ideas, just share me an email or a message on LinkedIn, and I can work it out for you as well if you want. So what I have here is I have a couple of workflows. Basically, for the demonstration, we have separated it out into separate workflows, basically separate actions as well, that point to a specific template. So if I would go to the action section, I can see here that I have these specific actions. Those are basically the template specs I also showed in the demonstration by using the local PowerShell option. And as we can see here, if we just click open one, it has two components. So I have a build section where I build out the template spec, and I have a deploy section. Why do I have a separate build section? As I can directly deploy the bicep file, I have that specific build section in there to be able to check on errors in my bicep file. So for example, there are some standard linting options, linting best practices, and everything else built into bicep. And before deploying any resource, I just want to make sure that I comply with all those default regulations. You can, for example, could also construct PS rule to check out and test things within your bicep template. So I want to have that first check enabled, and that's why I have that specific build stage. And then after that build stage, I make sure that all my files that I use and need to use for my deployment are specified in a specific artifact, meaning that later on I could rerun a specific version, or I can extract the files from that specific version and not reference directly into my main branch, for example, if I want to redeploy. So I always have those old versions ready to go with my deployments. Within the deploy section, I of course download the artifacts. I make sure to log in to the Azure portal. I have a specific composite action for this. And then I also update the template spec. But for example, it also knows the fact that if I have a change in here, it also automatically updates the version number so that every change or every deployment that's done on these files also make sure that we update the version number and we do not overwrite the existing version number. Because if you would normally run this exactly the same time with exactly the same version number, it would just override the version. So I want to make sure that it overrides the version. And that's why there's just a simple PowerShell script. Go to version, which is good. This is basically a very basic PowerShell script that basically just extracts all my template specs. So it gets the template spec with a specific name that it gets during the automation. I check if there's already a version. If there's no version, we will just start off with 0.1. If it has a version number, it will just make sure that it updates the version number with, for example, if it's now 0.1, it would create 0.2. And if 0.2 is there as well, it will go to 0.3, for example. So it's really a very basic versioning number. In any production scenario, you would really like to enhance this as well. But this is just to give you an idea that you can incorporate this within your GitHub Actions and make sure that it's basically done automatically. So if I would look into the composite action that we now have to deploy the template spec, it's just a simple part where we download the artifacts that we saved during the build phase. We do a login to our environment. So this is basically with federated credentials configured. And then we do an action called upload template spec. That's just a couple of PowerShell actions where we get the template version number, we write out the version number, and then basically do a new AZ template spec to that specific location, pointing to our online location, where we could just, for example, if we go back to the actions, and then we just pick this one. It could really help you. So basically, these actions and these automations are also configured so that they are automatically triggered at the point that we change template files. Meaning that if I would make a simple change to one of the template specs, I would commit it to GitHub. It just triggers off this build directly and make sure that my templates in my production environment, for example, if I would write this completely out, are up to date and running for my end users. Of course, any reference that there already are to these templates need to be updated to the new version. But people that use the interface, for example, to deploy new versions can directly use the new versions. So it's also completely backwards compatible where your automations still keep running because they reference maybe an old version. And they just need to be aware of the fact that they need to upgrade. So that, for example, if we set an additional property on one of the storage accounts, that they know, okay, next time we will do a deploy with a new version, so that we are completely compatible with all the reasoning within our own environment. So I've now talked a lot about Azure Template Specs, what you can do to them, how they work, how they look like, what the capabilities are. So I think you have already heard a lot. So basically, what I still want to give you guys is basically a reference, and I see that the link name is incorrect. It's pointing to the deployment stacks name. Yeah, it's the wrong one. It's cool, but it should point to the template specs name. That's just the other link. So basically, let me just point it out for reference. To learn more about Azure Template Specs, how you can use them, how it works, most things that you can also read in this document, we already covered during this session. So you are able to look there as well. And also pointed to my personal repo. That's just a public repository where you can extract the templates if you want. You can fork the repository, do anything with it that you want. You have seen the GitHub actions. In that repository, there are also ADO pipelines that do more or less the same thing with the template specs. So you have two options to do your automations and look at how you can get started. That basically leaves me with thanking you for being with this session. I hope you guys enjoyed it, and I hope I learned you guys some things about template specs and how you can use them. If you want to keep in contact, you can use the regular channels. You can find me on X or ping me on LinkedIn. If you want, you could also just send me an email. And that was basically it. Thank you, guys.
Thank you very much. We have one question. Let me share on the screen. Yeah. Did you see the question?
Yeah, I see the question. I'm still looking for the pros and cons. What would be specific reason to use template spec? Specific reasons to not use template spec. Yeah, that really depends on the situation where you are with your customers and what you would like to do. So a practical reason why we use them at this point is that we have some customers that really want to do and deploy research themselves, but are not completely aware of the fact what they need to configure and how they need to configure it. So for that reason, we created specific template specs for those resources, where we do the complete configuration for them, so that they do not have to do it afterwards. Because not all things that we want to do were, for example, also possible with Azure policies and adding those functionalities there.
Okay, great. I think there is no more question, and we can close this session. Thank you, guys. Thank you, Maik, again for this session. Have a good day.
Thank you, guys.
Bye-bye.